as I said, I just want to go over a couple of the important details, specifically with numbers 1 and 2. I want to be able to be a little bit more efficient with these, so again, pencils off. Yeah, if you want to grab a marker. For the rest of the day, Ivan, you can grab a seat in any of the groups that have an open desk, except for the force. It's the only one you can't sit. I think that is a fair thing to say.
Everybody else is food.
They're not,
We're not.
and they're not. So yeah, you can sit with the queens or aces.
Just the kid, like,
Why that tickled Rihanna so much. Got some laughter going.
Wait, can I sit right here, but like we could do like groups, not go with them?
That's perfectly fine. Just don't get distracted by the force.
How is that so funny though?
All right. So hey guys, first things first. Number 1 here that says 3 times x minus 3 times 2x minus 7. Technically, could I distribute and get to my standard form?
Yeah.
Yeah, 100%. But I need you to remember, what is the only form you don't want to solve a quadratic in?
Standard.
Oh yeah, you don't want standard form, right? So please remember, we don't want standard.
Inverse.
Hey, it's already effective.
Hey, thank you. I'm with you, but I saw some people with numbers 1 and 2 going to standard form. Now here's the thing, can you still make it work if you go to standard form?
Yeah, but
Yeah.
It's more work.
It's more work, right? Like you could use the quadratic formula, you could use the distance from the line of symmetry, you can use all that, but remember, identify what it is. Like we have factored form here, as Ivan pointed out, so what's really efficient when you have factored form?
Zero product.
Right. Guys, we can apply the zero products property right away. What if 3 times x minus 3 times 2x minus 7 is equal to 0, what do we know?
Do you know?
What do we know? Huh? Okay, first off, Walter's right, the 3 does not matter. Why? Because we have to be multiplying by a factor of 0. Is 3 0?
It's, well, no, it's not. But
3 is not 0.
When you what's the name, it's gonna be 0.
Oh, 3 it ends up being a root, yes. But this 3, that is not 0, is it?
No.
So I don't even have to worry about it. So what do I know? That's what I'm asking. What can I do from here?
Zero product property.
But like, how do I use that? Like, we're using the zero product
X
property.
minus 3 equals 0.
Okay, so x minus 3 equals 0. 2x minus 7 equals 0. Remember, one of those factors has to equal 0. Guys, when you have a product of 0, please set your factors equal to 0. And labeling zero products property here goes along with what's the best method to solve, right? Justifying it. Hey, I've got a product of 0. Now what do I want to do?
You can use either one, turn x into something that
Can't you just plus
that
3?
gets you 0.
So I need to make it 0, right? So I could do what? Plus
3.
3, okay? So if I
Plus-
add 3 to both sides of that first equation, what's negative 3 plus 3?
0.
All right, boom. And so what does x equal?
3. Positive 3.
Positive 3. Remember we had to add 3 to both sides, Penny? Okay, yes.
Yeah, I did mine different too.
How'd you do it?
I did mine different too.
Oh, I distributed. I did 3x, but then I put it both in parentheses.
So you did the 3x minus 9 equals 0?
Yeah.
That can work, but notice that's just a little less work. Because remember, the whole idea is that one of my factors is 0, and so like that's what Walter was saying earlier, does 3 equal 0? So that factor is a non-factor, right? Like, we would not have that be the case. So yes, you can distribute that 3, but you don't need to. It actually just adds a little bit more work.
Well, that's the way I.
Yeah, but I mean, like, I'm not saying you're wrong. I'm just saying that's something that can save you a little bit of time. Okay. You could have done the same thing to here. Like, it had to be to one of those two, though, just not to both of them. And just also remember, distributing gets us to standard form. We don't need standard form. Set your factors equal to 0. All right, what do I want to do with this factor?
Move to 7. So
What do I
plus
do?
7.
Plus 7. Okay, so minus 7. I have a negative 7, so I add 7. And what do I do to 2x equals 7?
Divide by 2.
Divide by 2, or take half, right? The reciprocal. Nice language, I like that. So 7 halves, 7 divided by 2.
Ooh, I got that right.
There's my roots. There's my zeros. Those are my solutions. Okay, so please don't forget, when you already have factored form, don't make it harder than it has to be. Use your zero product property. Okay, any questions on that number 1? We good? We understand how to fix this hopefully after a couple of weeks getting there, because we got tests on Friday. Okay? Number 2. Hey guys, I got 2 questions for you. What form do we have? Vertex form. And how many times do you see that variable? Once. So what's the most efficient method to solve that one? Yeah, we use the order of operations a little bit, but that's not the strategy. What are we going to use to solve this? Inverses with? Properties of equality. Guys, if you change one side of the equation, you got to change the other by the same amount. We actually used inverses with properties of equality right here as well, once we used our zero products property. Guys, if you, and notice how many times do I see my variable? So I use inverses with properties of equality. How many times do I see the variable here? So I use the inverses with properties of equality. If you only see the variable one time, the inverses with properties of equality is a great option every single time. Now, you mentioned order of operations. That's that PEMDAS idea, right? Because when I look at this, x is being subtracted by 4. So remember, I like to list it out. It's minus 4, then what's happening to x minus 4? It's being squared. Then it's being multiplied by 2. And finally, after all of that, is it subtracted by 8? Okay? So remember, that last thing being done, that's the first one I want to undo. That's the sake of efficiency, okay? So there we go. Now what? Divide by 2, right? It's going to undo the multiplication by 2. So what's half of 8 again? 4? Alright. What's next?
Square root.
Square root, right? Notice I'm going through all these using that inverse. The inverse of that square is a square root. So x minus 4 is equal to, so positive 2 and negative 2. Do not forget, when you take a square root, that's when you get a positive and a negative. Okay? So what is x equal?
Plus, well, 6.
6 and 2.
Two.
I didn't write it out and like you did. I just put a plus sign and a minus sign.
That's fine.
We got that right.
Did you get the
I got it.
the 6 and negative 2? Yeah, that's fine. Oh, I see what you did. Yeah, I like seeing the inverse in there, but it's equivalent. Okay. Now, Amaya, did you end up getting those same answers at the end on number 2? Oh. You tried multiplying it out though, right? Squaring that x minus 4, is that right?
Yeah.
So this is why I was bringing this up. I do want to remind you, you can do that, but if you square that x minus 4, like, it'll just take extra time. X minus 4 squared is going to end up being x squared minus 8x plus 16. Is that what you got right here at this point? Then you got to distribute your 2. Whoops. But notice how there's so many places to make mistakes this way. And then I got to subtract the 8. And that's equal to 0. Is that the standard form you got? No. So there's somewhere along the way that you made a mistake in there. Does that make sense? So like that's the thing. You can do it this way. You can get to that standard form, but then you can go back to the vertex form and use inverses. What else could I have done to the standard form at this point? The area model to help me what? Starts with an F?
Factor.
Factoring, right? But the whole point of that area model is it helps me go from standard to factored and factored to standard. So could I use the area model to help me factor it here? Sure. Should it give me the same exact roots? Yeah. Oh, that's supposed to be an X right here. Let's see. Yep. What are factors of, so I had a GCF, so I.
Is Jaden Crenshaw in class today?
He is not.
Thank you.
Yep. What are factors of 12 that add up to -4? Or, sorry, -8. Yeah, that one. 6 and 2, but they both be negative. So I am jumping, I'm not using the area model, but it works out this way. Notice how my roots would be 6 and 2. So can you do it multiple ways? Any guesses what I would get if I use the quadratic formula?
Probably 6 and 2.
Probably 6 and 2. And if I use the distance method, I would probably get 6 and 2. Okay, so you can use whatever strategy you want, but again, like what's the most efficient? That's what I want you thinking through. Okay. Really quickly, yeah, I'm going to go ahead and move on to the.
Did
You
you
wanna
do
go
all
over
these
4?
problems?
You didn't do 4? We're not going to go over all of them today. I'll score them, and Mr. Anderson will score them during first block tomorrow, and we'll give them back to you tomorrow and maybe go over the last couple. But 4 was giving you trouble? Did 4 give anybody else significant trouble? Okay, so let's look at 4 then. Okay, so Walter, what was the first thing you tried doing in number 4? You tried using the area model right away from here? Okay, good. I'm glad that you pointed that out, because guys, here's the thing. Area model would not work right now. I mean, you could try to factor it, but the area model wouldn't be helpful, because once I get the factored form, I don't have a product of what?
0.
0. But if I subtract 3, alrighty. Now, let's think about that area model. Now, here's the other thing. Could you have used another strategy if area model wasn't working out for you?
I use the negative b plus like that. That's what
Negative b,
then the square root, or plus or minus square root b squared.
use the quadratic formula. Yeah, that can totally work too. Now, I will say you could use the area model here.
I have a question.
Yes, ma'am?
Could you have added 1 instead of subtracting by 3?
No, because that's a good question. But remember how it's quadratic and linear here? It's x squared and x to the first. So like I can't do anything once it's 2x squared and negative 7x equal to 4. That's just not going to help me. But by making it equal to 0, now I could use the quadratic formula. I could use the zero products property if I get it to a factored form. But you never want a quadratic and linear on the same side and a constant on the other side. So good question. If you want to make a note about that, that's probably a good thing. On the factoring side of things, remember, I need factors of what that add up to what?
You need factors that multiply -4 but add to get -7.
So here's the issue though. If you did that, there's nothing that works. But it's not actually factors of -4. It's not -6. Remember, it's A times C. What's A again? That's, what's A? 2. What's C?
-4, so it would be -8.
So you need factors of -8 that add up to -7. So if you forget that AC detail, could you use the quadratic formula? 100%. But what are factors of -8 that add up to -7? -8 and 1. -8x plus 1x. So we get x minus 4 and 2x plus 1. So there's your factored form. And when you solve it, 4 and -1/2.
Oh my God, I got them right.
So, but use the quadratic formula instead.
That's number
I
4.
need the quadratic.
Oh, I got that right too.
So, here's the thing, guys. There's more than one strategy available to you, okay? So, keep that in mind. And I'll say this, on the actual test, I'll have some where it's just x squared that you can factor, and some that are like that, 2x squared. But you've got to find factors of A times C that add up to B. And if you don't see it, pivot, right? So Walter, you don't see that? Try using the distance method, try using the quadratic formula, try using the vertex form. So if you get stuck, pivot. Finally, okay, I'm going to erase the stuff on 1 and 2 because I'm going to assume that everyone wrote down what they wanted on 1 and 2. The final thing before we move on with today, please make sure you put your DYUs together, and I'll come by and grab the groups. Yes, Benny?
Can you do number 3 before you do the final thing?
No, we'll go over it tomorrow.
We got 3, you want
Yeah, we got
Yeah.
two.
At that point, might as well just not over all of them.
I don't know.
I guess I can't go over number 3, it might help them later today. But what I want to remind you of is this, you all had graphing calculators, didn't you?
Yeah.
If you were completely stuck or you wanted to check your answer, what could you have done with each of these to find the solutions or to check yourself? What do you mean plug it in? What does that mean?
Put the equation in the calculator or in the graph.
Okay,
Would you
so
press add graph?
I would say, if I add a graph, now here's the thing, could you substitute values into the equation and see if they make the equation true? Yes, but you also already have to have solutions there. But could I graph these?
Mm-hmm.
Yes.
So add graph, 2x squared, is it minus 7x? Yeah.
Yeah.
Now do notice I need the minus 4, because it needs to equal 0 so that I can find the what on the graph. What am I trying to find? What am I trying to find on the graph? The x intercepts, but what's another word for those x intercepts?
Roots.
Zeros or roots. So it has to equal what? 0. Hey, I want to point out, just glancing at it, what does it look like this x-intercept might be? Negative 1/2. What does it look like this x-intercept is? 4. But remember, you have a graphing calculator. If you are completely stuck, please don't sit there and do nothing. Like, use your graphing calculator, because you will have a graphing calculator. So I want to see that you can do it algebraically. But if you can do that, can you find roots?
Mm-hmm.
Now, the unfortunate part is, this strategy will not always work based on what we're about to do today.
Oh,
You saying like the graph won't work?
It will
Well, I never
work
use it.
for most. Well, but it's totally okay to. Like, legitimately, guys. Use it as a strategy if you're stuck.
Mr. Kenny,
Yes, sir.
can I rush the restroom, please?
You better run like a wind because I'm about to start.
Yes, sir.
Alright, so I'm about to come collect your DYUs, but before, or while I'm collecting the DYUs, I need you to get out,
Come on,
we're going to come back to these, I need you to get out this task that we worked through yesterday, the discriminant and types of solutions. This is what Mr. Anderson ended on teaching you yesterday. I'll go over it tomorrow, okay? Don't forget. I like the labeling of the R1 and R2. Because I like the labeling of R1 and R2.
Yeah, you taught me that.
I know. Those indeed are our roots. I like the notation also, the x-intercepts, and recognize that. I think I like the recognition of the x-intercepts. There we go. Alright.
Nope.
Alrighty, so, quick reminder, discriminant types of solutions. Remember, what was the discriminant yesterday? Mr. Anderson talked about this.
He was talking about the real and
Yes, but like the discriminant was a part of my quadratic formula.
what is it, the B? The B
Not the
squared.
B,
The B squared.
it was not the A,
The B squared.
it was the what? It was the entire radicand, okay? If you missed that detail yesterday, the discriminant is a special name for this radicand. Not all radicands are discriminants. The discriminant is the radicand for the quadratic formula. Let me go ahead and tell you this. I don't care a ton if you know that word. I don't even think that's on your proficiency scale. But you do need to know the term radicand because the radicand is located where?
On the right.
Under the radical. You gotta know that. Here's why this does matter though. So if b squared minus 4ac, your radicand was
That's
greater
two
than
real.
0.
That's two
There's
real.
two real
solutions.
solutions or roots or zeros, okay? If b squared minus 4ac was greater or was equal to 0,
It was one real
it was
solution.
one real solution.
And then the other one's two imaginary solutions.
Can I have the pencil back?
No.
Anyone remember a special term for when it was that one real solution?
True.
It was a something root.
Is the hour?
Maybe we didn't introduce this term yesterday.
The hour?
No, that was later. That was a double root.
Double, yeah.
Okay? And if b squared minus 4ac was less than 0, because remember, here's what we're really saying. This is the radicand, so I'm taking the square root of what kind of number if it's greater than 0? Square root of a...
Perfect square.
Right. I don't
What
know.
kind of numbers are greater than 0?
Negative.
Greater than 0
Oh,
is a
they said
negative?
less than 0.
Imaginary.
No, guys, sorry. I'm coming back up to here. Greater than 0. What kind of numbers are greater than 0?
Positive.
Positive, okay? So, what are we saying? We're taking,
Positive.
well, a square root
Of a positive.
of a positive number. That's what we're saying here. We're taking the square root of a positive number. That's why we got two real solutions. Here we're taking the square root of 0, so we just got one real solution. But here, we're taking the square root of a what? Taking the square root of a negative. Taking the square root of a negative number. So how many solutions or what type of solutions did we have? Two imaginary. And we looked graphically at what that was like yesterday. So I'm going to give you time to take some notes in a second. But something like b squared minus 4ac is greater than 0 could look like this or like this. What was it when it was a double root, the one real solution? What did it look like?
I think it was like
The vertex was on the x-axis, right? So it could be concave up or down, but that vertex is on the x-axis. And then what was it like when we had imaginary zeros? What was it like when we had imaginary zeros? What did the graph look like?
it was an, I think it was negative. No,
Kind of, huh?
It was,
it was upside down.
No, wasn't. Look back at your C on the other side real quick. Did you get a graph down there?
I just said it was like that.
It was down, but more importantly, it what? It doesn't touch the x-axis. So notice it was below the x-axis and went down, or it could what? Be above and go up. So remember earlier on when I was saying, hey, it's not always going to work to be able to graph it? When you have what kind of roots, is it going to be impossible to use the graph?
The two imaginary?
The two imaginary, yeah. So that's one of the big reasons why we have to have some algebraic methods available, because if there's imaginary roots, graph isn't going to help. Okay? We have to have some algebraic methods, because if you have imaginary roots, the graph is not going to help. Yes, Benny?
I didn't have a question.
Alright, I'm going to wait for a second for you to get those notes down. I would do a sketch of the graph to compare it with. Do you not have the page? Do you want to copy? What'd you do with it yesterday?
Oh, it's on my phone right now.
Huh? Oh, you don't have your binder on you? Let me see if I can find the extra copies. Haha! I found an extra copy. Here you go.
So what we can do?
We're gonna look more at the imaginary solutions and what an imaginary number is. Because here's the reality. In order to solve for imaginary solutions, you're going to do exactly the same stuff we just did. You're just gonna end up with the square root of a negative. It's the only difference. So we do, one, need to know how to simplify those radicals to get that I. And two, we need to know how to add, subtract, and multiply imaginary numbers. And guess what? It's actually really easy. Huh?
How would do that?
We finna go over.
Say imaginary.
We finna go over.
I know, right? How do we do that if it's imaginary? The KB, you're still taking notes? You're done? Okay. Anybody else still taking notes? Oh, yeah, sorry. Do you have your iPad on you? Okay, take a picture of it real quick, just because I think everybody else is done. And then put it into your notebook later.
Miss Kitty, you ain't even look at that thing I told you.
Oh, you right?
But I remind you at the end of class.
No, I'll look at it right now. You said it was the last section of Delta Math? 'Cause
Oh, yeah, it be say, like, you can't put an answer on there.
Yeah, then it's tripping when you try to click on the fake keyboard on the thing, it puts your real keyboard. I don't know, I can't explain, but
You said it was the last section?
Yeah, the very last one.
The last one.
Huh? I don't know. More than just look. Well,
Is it this that you're referring to?
yes.
Okay. So it says solve for x using the master product. I hate that term. The master
Did I even search
product.
out the master? Because we didn't talk about it. I don't know if we did.
The master product is just the AC method,
Oh.
A times C. You need factors of A times C that add up to B.
Huh?
It's just, you need factors of A times C that add up to B. So, remember how you tried to factor that one earlier, and you're like, oh, factors of -4 add up to
Oh.
-7, but there weren't any. We had to do A times C. That's the master product, I think. So let's look at it. Yeah, sometimes mathematicians have used different terms for different things. That's one I actually hadn't even seen until I've done this. But master product, so A times C, 5 times -8, -40. So let's try that as our
So that's
master
all you
product.
do.
Huh?
So that's all you doing.
Nah, to start, I think. Let's see what they say. Yep. So you had to get the master product to start. Now we can factor this. And they're asking for the final answer from here. Notice how it says x equals at this point. So 5x squared minus 8. What factors of -40 add up to a +3? Okay, let's start with -40. What are the first?
5 minus 8.
Okay, 5 minus 8 is close, but not 5 minus 8. Say again.
8 minus 5?
8 minus 5. Right, we needed a +3? Okay? So you can just walk through your factors, by the way, don't forget that. Okay, so when I look at this, I see an x in common, a -1, a 5x, and an 8. Let me check. 5x squared, well remember I'm multiplying these, right? 8x, that'd be a -5x, that'd be -8, yep. So my factored form is 5x plus 8 times x minus 1. So I'm going to jump, because I still want you to work through it, but I'm going to get this root and this root. I think they just wanted you to put in a comma between them. Yep. And then -8 divided by 5.
Okay. Thank you.
Yep.
Okay,
That's all I was
what's
doing.
the next one real quick? Is it the same way as you do?
Yeah. The same thing. Yep, same exact thing. Okay, thank you for asking that question. But yeah, that's just the AC method of factoring. That's why I actually picked that problem to help you practice that skill. But I forgot that they asked about the master product there, which is key. Okay, so the second part of yesterday's lesson is where this really comes to be a thing where we're looking at imaginary numbers. And that's where we're going to spend the majority of our time today looking at imaginary numbers, solving quadratics with imaginary numbers. Once again, the solving method actually does not change. But remember yesterday I showed y'all how to simplify square roots, where you find the perfect square factors. So you need to find a perfect square factor like 16 and like 5. And so, because I can take the square root of 16 and I leave the square root of 5, okay? So we're going to practice some more with that today. But yeah, adding and subtracting and multiplying imaginary numbers, simplifying square roots with negative radicands, and solving quadratics with imaginary zeros. Yeah, we're going to skip that, because we just don't have time. Skipping that. Okay. Let's get to that in a second. Picking up with something we did yesterday. What was the... let me go back, I guess. Make sure I have the right equation. Here, let's do this one. This check your understanding. This is on the mathematic task that we did yesterday. We're just going to look at number 2. You don't need to get to vertical surfaces because I'm just going to give you a couple of minutes. Not even a couple of minutes, a minute or so. I want you to find the discriminant of x squared plus 5x plus 10, and I want you to identify how many solutions this function will have, right? So you should have the notes right above it. Find your discriminant, figure out how many solutions this is going to have, okay? So this is where we're going to pick up. Yep, on the back of that, right there, Victoria. So just talk with each other. It's just this right here.
Somebody at the door.
Good morning. Jump in with the queens. I think they're the ones that have a space open.
No, I haven't been
Raise,
right here.
Who is right here?
You, when we get up.
So don't
Yeah,
forget, guys,
you can't
we're
say
working with
it
each other on finding that discriminant for number 2, Carly, not number 1. So find your discriminant for number 2. That was the DYU we just did. If you want to go ahead and just knock that out while we're working through other stuff, you can. Or you can engage in what we're about to do. Where is your paper? Oh, how did you lose it so quick?
You see why you can't sit there now?
Literally the only group I told y'all not to go to is 4s because of this garbage. Have you even tried 2A yet?
Miss Kennedy, what you talking about?
I'm just so lonely like this. So
Well, then go to the group, one of the groups you can. Apparently only aces at this point. Yeah, discriminate,
I
right?
can't go to 4.
So how many solutions are you gonna have? Did you actually find the discriminant?
I don't talk to nobody at the 4. You don't want to go.
All you do is talk to somebody in the 4s. That's why I don't want you in the 4s. You literally were 5 seconds ago, bro.
It's crazy because you
Don't.
literally do good.
Have you done? No. At any time C, what does it say? The
But
discriminant.
wait, you don't have to talk to me.
Mr. Finney, dog, you literally have the discriminant written above in the quick notes. Have you read the quick notes?
I read it. Taking the square root of a positive number.
No, dog. B squared minus 4AC.
I know. So
I know. So
so
what's
I
your
just-
A? What's your B? And what's your C?
A is 1, B is like
Oh, look at there. Look at there.
gonna be 5 squared plus 1. It's 0, okay. 1.
Yeah.
Yeah, 0, it's a double. Oh my god, bro. This can't be true.
So many numbers.
So, my discriminant b squared minus 4ac is negative 15.
Mhm.
How many solutions and what type am I going to have? Two what? Two imaginary? Finney, do you agree? Why not? Why do you want to push back?
Without,
Huh?
it was in the calculator, it was 0. But Abby put 10 squared on accident.
Okay, so, but there's my discriminant. I'm telling you that's the discriminant. What I was told was because of that discriminant, that negative 15, two imaginary zeros. Brianna, what do you think? Agree, disagree, want to push back? Agree, why?
I don't know.
Okay. Job, what about you?
You don't know. What was the question?
I agree with
Do you agree that it would be two imaginary zeros or solutions?
Yes, it's a negative number.
I agree.
You agree? Okay, so why would that negative tell me that we're going to get two imaginary?
It's negative.
Because it's
taking a square
less than
root.
0.
It's less than 0. We're going to take the square root of a negative 15. And square roots of negatives are?
Two recipes.
Man, you just told me imaginary, dog.
Imaginary. Hold
Type the square root of negative 15 in that calculator. What do you get?
on. 3.
It's a non-real calculator.
It says non-real, right?
Or not somebody, yeah.
Yeah,
Because you
something like
can't do
that.
square root of negative.
Okay. Well, but here's the thing. We couldn't square root of negative. We're going to see this more in the open up resources task that I gave you. But remember, and I think I mentioned it a couple days ago, or I guess this would have been on Friday, we realized in mathematics that we needed to be able to take the square root of a negative. The square root of a negative kept popping up and popping up and popping up. But what's the issue? Why have we not been able to take the square root of a negative up to this point? Well, not this, yes, for the square root of negative, but here, let's say I take the number 3 and I square it, what do I get? I get a 9, positive or negative? Positive. Let's say I take a negative 3 and I square it, what do I get? I get a positive 9. That's, make sure you put parentheses around it, Dalton, because it'd be negative 3 times negative 3.
Oh.
What's the square, or does anyone know what 1/2 squared is?
0.5. No.
Well, it's 0.5 times 0.5, but I would remind you, we're just squaring it, so what's 1 times 1?
0.25?
And what's 2 times 2?
4.
So it'd be 1/4, which is 0.25, yeah. What would negative 1/2 squared be?
Negative 1/4.
Not negative 1/4,
Positive.
it'd be a negative times a negative
0.25,
again,
yeah.
right? Okay, 0.25 again. So, remember, any real number squared gave me a what?
Positive.
A positive, right? Let's reword this, any real number squared is positive. This is the problem. This is the problem we ran into. Because essentially what we're saying with this, we need something squared that equals negative 15. Does any real number squared equal a negative 15?
No.
No, because any real number squared is
Positive.
positive. Okay, so I'm going to bring this note over here. This is what you're going to want to make a note of here so that you can bring it up later. Here's what we need to be aware of with this. Mathematicians knew
I hate mathematicians. Yourself.
we need, well, hold on a second, something squared to get a negative. And they came up with a solution. They created a number, / discovered it. They made the number I, and they defined I so that I squared equals -1. So that's something I talked about briefly last week. Literally, they discovered that they needed this. And I know like some of us are thinking, by the way, does anyone remember what we mean by I, like what that number I is? It's the imaginary number, which makes us think that it's not what?
Real.
Not real. But I'm going to caution you and I'm going to push back on that. I is a real number, just not what we mean when we say real number. The reason I say that is, you know, your cell phones that you love, you know, the iPads that you work with, the calculators you have in your hand, anything associated with technology is built, yes it's real, is built on using the imaginary number. No, like you have to use the number I to understand how electricity moves and works. Things that follow a wave-like pattern can be modeled with the imaginary number. So, it feels like, yes, frequency. Things that have a frequency can use I to model them. And so it felt like it could not be real, so that's why we called it imaginary, but it's an actual number. So it's not a real number, but it is an actual number. So don't think otherwise. Okay, but if I squared is equal to -1, what is I equal to?
No.
Huh?
Yeah.
If I squared is equal to -1, what does I equal?
No, positive.
Any negative number?
Not any negative number. Okay, let me grab a different marker. Really quickly, I want you to think about this. What could I do to this equation to figure out what I is? Oh, I can take a square root, right? So what does I equal? Don't make it hard. Look at what's literally up here, Melanie. Don't put it in the calculator. It's the square root of -1. Isn't that literally what this is saying? If I squared is equal to -1, I is the square root of -1. If I squared is -1,
Where do you get 50 from?
50?
Where you saying 58?
Yeah. So! That's the word so, dog. Gotcha. Sorry. That is the word so. I see where that confusion is. So, I is the square root of -1. I squared is -1. I need you to be careful about that. Because I squared is -1, I is the square root of -1. That's just a definition. Huh?
I did that.
You did? Okay. Making sense? Ish? Yeah? Good. So, remember earlier, I'm gonna just to point this out. Remember earlier how we had the square root and we would have had the square root of -15. That's why we said it was an imaginary number. Remember how we simplified radicals yesterday so that we could split it into two different radicals? KB, you awake? You with me? Walter? Like, this is about to be foundational. If you don't get this, this is going to be problematic later. Victoria, I need eyes up here. Dee Dee, I need y'all to attend to this. So the whole idea is that I is the square root of -1. Bringing that together with what we did with radicals and simplifying radicals yesterday, I can rewrite this as 15 times -1. Can we all agree 15 times -1 is -15? Okay? From there, based on what we did yesterday, what two radicals can I split this into?
15.
No.
It's like radical 15 radical.
Well, square root of 15 times
Radical, square root radical.
square root of
-1? -1?
of -1. So, what was the square root of -1 again? 9. So if you get the square root of a -15, you have to know how to simplify a radical to at least get the number I out of it. So if you get a square root of -15, rewrite it as 15 times -1, square root of 15 times square root of -1, so square root of 15 times I. Now, you can also just go straight to the square root of 15I, but I don't recommend jumping to that point. But that's it. That is the majority of what you have to know with imaginary numbers. Now,
Are we here for that verse 36 today?
yeah, that's what we're about to do right here. So here's what I want you to do, okay? I'm gonna give you 4 minutes to work with your small groups on just coming up with what you think we would get when we square these two, square this expression and then multiply this expression. So think about what you already know, and let's simplify it, okay? So 4 minutes on your clock, ready, set, go. 11:12, we're gonna come back and talk about it. Come on. Just use the eraser that's right there. That's all. Just erase it. Oh, is that from yesterday? Wait, she's taking a BYU.
I was asking how you put it.
You can ask me, you can't ask other students. You can also just leave it as radical, that's okay.
Hey, Mr. Kennedy, where the spray at?
Right?
Dalton
Dalton
got
has some, there's another thing of it somewhere though.
it. Dalton, calm down, man.
Huh? You won't get a decimal enough when you get a square.
Oh, what's the
Think about
camera
what it
on?
means to square.
It was on.
Alright, it's more.
Okay, it's coming on. You just want to spray this one. You might know how to If you spray down my
Stop using the calculator. Hey, also let's do this to make your life easy. Start with B and then do A.
Hey,
Do
can I
B
use
first.
Do B, then do A.
Can you pick this for him so you can pass it to me?
Always mix
So 3i times 3i.
Spread.
Let me see the spray. Move the camera. I got time to play it, so give me the thing. Give me the spray.
Fence, doggy.
You alright?
I'm just not smart enough.
Cut it out.
3 square plus 3 square.
Good dog.
Here's the dog. Literally.
On the next episode,
Hold on.
Will Walter.
Hold on.
Will Walter.
Walter, what is that?
Go. Ivan, go.
Will Walter. Play basketball. We got a game today.
3 square.
I wear number 5. You gonna play ACA? You gonna get pants mid game when you try to shoot the 3?
You said what, y'all?
You gonna pants
Alright, 1 more minute, we're
Are
gonna
you
talk
pissing?
about.
Hey, Mr. Kennedy. Mr. Kennedy.
Yeah.
We did an interview. Hey, that big old YouTube. Dog.
Really quick note, Myra here. So you got
Punching me on camera and shit.
square root of 2i, rewrote that as square root of -2, right? So when you square that though, what's the relationship between a square and a square root?
Why they can't even see
In
me?
inverses.
My mom.
So what are you left with? Negative 2. We're gonna look at it a slightly different way, but notice.
Mr. Coriano.
It would actually be, we have to be careful about doing.
Mr. Coriano.
Well, first off, it wouldn't be 4i. It would be. It's
I saw
tricky.
that and I saw that.
It's, you can do it this way and let the square root and the square cancel. Literally, that's what you have. But there's another way I'm gonna show you.
I'm not saying
Alright, it's been 4 minutes, let's start talking about this a little bit, we're gonna get some practice with it in a second. So first off, 3i times 3i, what's that gonna give us?
3 square, 3i square.
Okay, so hold on to that, we're gonna get to that -9 later, but remember, literally what's 3 times 3?
9.
9, so 9. 9i
Square.
squared. Remember, anything times itself
That's the
is
Squared.
squared, right?
The answer?
No.
Not quite.
Oh.
Because how could I rewrite I squared? Remember, this was the whole important definition. I squared is -1. So 9 times -1 is -9.
So that's the answer.
That's the answer. 3i times 3i, that is also the same thing as 3i squared. Remember, what was the whole point of the number I? So that when you square something, you get a
Negative.
negative.
Oh,
Wait, what did you say?
-1.
Negative. Well, that's I squared is -1. But the whole point of introducing the number I is so that when you square something, you now can get a negative in general, okay? So, that would just be -9.
That's on our paper?
On what paper?
Like, do we have that problem on the paper?
What paper? Like, your next assessment?
my.
I'm
Oh,
saying-
yes, this is on the paper. This is on the second page,
Why do you think?
okay? I got you,
Nicole.
the task I gave you, yeah. It's the sheet after mathematics. Alright,
All right,
So-
Nicole.
now, A is a little bit trickier, but I do want to point out how Amaya approached it, and then I'm going to show you a slightly more traditional way. Amaya, what you did, correct me if I'm wrong, is you rewrote square root of 2 times I as the square root of -2. Why were you thinking that? So be careful, I is not -1, I is the square root of -1. So what we literally had was square root of 2 times square root of -1. So Amaya essentially works backwards from what we did before. Square root of -2. And hey guys, this is not necessarily the way I would have approached it, but what's the relationship between a square and a square root? They're inverses, right? They cancel each other out. So I get -2. That's totally valid. Remember, the whole point of I is so now when you square something, you get a negative. That's the whole point of I. So that now when you square something, you get a negative. What I would have done here, which doesn't change a whole lot. So, I know we always talk about how you cannot distribute exponents, but you can, you just have to know the right time. You can distribute an exponent over multiplication, because what is an exponent? Just repeated multiplication. So you can distribute an exponent to multiplication. Just like you can distribute multiplication over what? What can you distribute multiplication over? Addition and subtraction. Guys, you can distribute multiplication over addition and subtraction. Because what is multiplication? Repeated
Addition.
and subtraction. You can distribute an exponent over multiplication because an exponent is repeated multiplication. Okay, all that to say, that's the square root of 2 squared times I squared. That's all I would have done. And what's the square root of 2 squared? Not 4.
No.
What's the relationship between a square and a square root? So they cancel.
Out.
I'm left 2. And what's I squared? -1. So I get -2. So Amaya, what you did is actually really efficient, and honestly more efficient than this necessarily. Most people just don't see right away that I can rewrite that as -2, or square root of -2. So it works, it's just not what most people see. But you're just squaring it, okay? Because what it literally is square root of 2i times square root of 2i. I guess that would have been an alternate way as well. If you don't like it, remember, all that squaring is repeated multiplication. And square root of 2 times square root of 2 is 2. I times I is I squared. Same answer, -2. Notice, is there only one way to solve these mathematical problems?
Great shot when you did.
That answer is a resounding no. There's not only one way?
Great shot when you did.
I don't know what you said.
I
He
joined
said,
it.
great shot, Wendy Day.
Okay, so remember, big idea. The whole point of I is that I squared is
Negative.
negative. So when you square imaginary numbers, you get a negative. Yep. All right. That's the big idea there. That's it. That's simplifying that stuff. Nope. Okay. So now,
You go, John. You go ahead and get prescription.
we're gonna look at these four examples. Now, one thing I want you to be aware of, so this is 8. When I look at 13 plus 2i, how many numbers do you see there? Most people think 2, but actually,
It's 3.
it's only 1.
Oh.
This is known as a complex number with a real part and an imaginary part. Anyone want to take a guess what the real part of 13 plus 2i is?
13. First one go to.
Hey guys, listen. A plus bi, 13 plus 2i, what part of that is the real part?
13.
Just the
Just the 13.
Just the 13. Remember though, the whole point of I is that it is
Negative.
im-
I mean, imaginary.
Okay?
Yeah.
Remember there's a real part and an imaginary part, not a fake part, imaginary. The real part is the 13,
The 2i is the imaginary.
the 2i is the imaginary. That's it. So guys, when I add these two numbers, so notice it is only two numbers, I'm just going to give you 60 seconds, 90 seconds. I want you to talk about it with your group. How are you going to add those two numbers? Try to come up with what we would get when we add those two numbers together.
What?
Thanksgiving is in 9 days.
Who gives it?
Me?
Okay, you don't care what you eat.
I'm gonna barbecue.
Your brother said y'all fried turkey. How family can't cook?
I don't know, they eat them all at Walmart.
It's not my student.
No, you can write them up.
No, I might be doing the Columbus teacher.
There's another teacher right down.
He said y'all eat fried turkey.
My brother lying, you
Johnny.
know fried turkey.
John, would you go with Brianna? She's a friend. No, but you,
She's a what?
would you go with her though? No, but would you go with her?
Uh,
I don't go with my friend.
Two
No, if she wasn't your
mistakes.
friend, would you go with her?
Those are being subtracted, so you need to think about what that is
Stop trying
subtracted.
to cook, bro. You just
2, remember you square
Alright, you wanna cook?
a negative,
Go
you
ahead.
should
I
get
got a
a
girlfriend.
positive, but you wouldn't right now.
Whatever you say, don't hurt me.
It's weird, y'all are in different groups and you're still managing to talk.
I wasn't even talking to Johnny.
Oh my gosh.
Not a
Call us
mom.
that time.
Oh my.
You're full of crap.
Okay, you caught us. You caught us.
You call us that time.
Oh, that time.
Oh, you caught us. You caught us.
You understand that I record almost every day in this class? Like, you know how many times I've caught you?
Oh.
No matter what.
Deny till you die, I got it. Alright, number 8A right here. So what do we think we would get when we add those two numbers together?
Somebody the 13 and the I don't even know what I'm looking at. It's so much stuff on the board.
Negative 12.
Okay, 13 plus negative 12 would be what? That'd be
Where
1.
y'all get negative 12 from?
Oh, yeah.
What?
Here's the thing, can I take a real and add it to an imaginary?
Yes.
No, one part's real, one part's imaginary. I can't add those two together.
Like term.
So I add like terms, that's it. Hey guys, adding and subtracting complex numbers. Again, complex just means there's a real part and an imaginary part. You put the reals with the reals and the imaginary with the, so what's 2i plus negative 5i?
7i.
Positive 2i minus 5i.
That's negative 3i. Yeah.
Now, that's just putting the answer. If I were you, what I would do is I would do 13 plus negative 12, put my reals together, plus 2i plus negative 5i. Notice all I did was I put my reals together and I put my imaginaries together. That's it.
I don't like you.
So now you just solve it from there?
I just simplified. I didn't solve anything. I'm not finding what makes the equation true. I just simplified.
Oh.
Right? 13 plus negative 12 is 1. 2i minus 5i is negative 3.
It's okay.
Alright, I get it. Okay. So that one negative 3i would be the answer.
The 1 minus 3.
Well, 1 minus 3i.
That's one number, but yes, 1 minus 3i.
Alright.
Okay? So like, in part B here, negative 7 is going to be, what's added to negative 7?
What's added to negative 7 is 3.
It's 3, yeah. Plus what's being added to the 12i's? Be careful, not 6. Negative 6i. So what's my final value? Negative 4.
You know that's unreal.
Will just become not negative 6i, positive 6i.
I thought I is negative.
No. I is the square root of negative 1, and I leave the I there unless I have an I squared. If I have I squared, I rewrite that I squared as negative 1, but I is I.
So do you solve that?
Aye, Captain.
No, we're not solving anything. I don't have an equation. I simplify it.
And I still.
That number. I have all the reals together, I have all the imaginaries together.
One of your things. Merch.
I
Okay?
already did.
No, I didn't.
C. What would I do here in C? 8
Minus 7.
minus 7.
1.
What do I need to do with the imaginaries? So, negative I,
Minus.
Well, I wish a motherfucker would throw C.
is it minus 3i?
That'd be easy to add.
Minus a negative 3i.
Column drop.
That's important, because when I subtract a negative, I need to end up
Positive. I mean negative.
adding.
Oh.
When you subtract a negative,
You
end up
add.
adding, okay? So, what's 8 minus 7? Negative I plus 3i would be
It'll be just.
negative 1
Wouldn't
plus
it,
3.
wouldn't it be 2?
So it'd be 2.
2I.
That's it.
Oh, this kind of this easy.
It's just adding numbers.
That's
You
really
just have to
hard.
recognize real goes with
Real and
real.
imaginary goes to imaginary.
imaginary goes with imaginary. That's it. So group your reals, group your imaginaries.
What is you looking at, Mr. Coriano?
No. When you subtract a negative, that ends up adding this number. Okay? Alright.
Until you shut up and I'm
Hey.
slapping you.
No. This is why y'all talk.
That is a
Stop touching me.
You know what I'm saying?
Right
You
up.
sit down.
Phoenix, sit down.
You make me overstimulate all that walking around.
Okay, start looking at him then.
Please make sure you have those answers down for A, B, and C. I want to look at 9A. We don't have a ton of time, so I'm just giving you 60 seconds on 9A and think about how you're going to do it. I know. So look at 9A, think about how you're going to tackle it. 9A. Well, not time yet. You need to see 9A.
3 plus 2, 5 plus.
Wait, Mr. King, plus 5 plus I.
Look again, what's happening between those parentheses?
Multiplication.
They're being multiplied.
What?
How would you
Like right here?
multiply those? Yeah, that's understood.
So
No,
now,
between the parentheses.
so would it still be 3 plus 5?
You got some ram right
Multiplied by like.
You got some ram right
Would it be?
Let me ask you this, if it was 3 plus 2x times 5 plus 7x, what would you do? To
Multiply
multiply?
3 and 5 and then multiply 2 and 7.
Is that all you would do? If it was 3 plus 2x times 5 plus 7x. Look at what's right above it.
I didn't use all 4.
What did they do?
Don't.
I've been using.
What does that look like to you?
So they multiplied the 4 and 3.
Not just that. They multiply the 3 and the 4, but like what are they using here?
They are.
Oh, they're using the area.
Oh, sound like something I'm doing tomorrow.
Oh, what they be saying?
Alright.
Thank you.
So,
Hey,
hey guys, be careful
hey.
with the operations that you see, because when I look at these parentheses, what's happening between those parentheses? They're being multiplied. And so I pointed this out to the group in the back, and I want you to notice this. If we had 3 plus 2x times 5 plus 7x, what would you use to help you multiply, Brianna?
Area model.
I would use that area model to help you multiply. You know what I'm going to use with these imaginary numbers?
Area model.
I'm going to use the area model. Now remember, the area model just helps me distribute. That's all it is. So if you want to just distribute, you can. But this is what I would do. 15 plus 10i. 7i times 3 is, hey guys, stop. Y'all got 2.5 minutes. Let me get this out and then you come back. What's 7i times 3? 21i.
21.
And now this is where you gotta be careful. What is 7i times 2i?
14 squared. 14 I squared.
14 I squared.
Okay. So what do I have? I have 15 plus 10i plus 21i. Now, how can I rewrite 14i squared?
You can write 214.
14 for I, parentheses, and square.
Well, but what was the whole point? I squared is -1, so this would be minus 14. Remember, that's 14 times -1. It's minus 14. Now I have some real numbers, and I have some imaginary numbers. What's 15 minus 14?
15 minus 14 is y. I mean 1.
What's 10i plus 21i? That's it. Guys, just use your area model to help you multiply. If I were you, I would do the last question from number 8 tonight, and I would do the 9, so I would do 8D. So that's actually, hey guys, I would finish numbers 8, 9, and 10 to help you prepare for class tomorrow.
How you do it?
And that's it. Hey, Ivan, which questions are you going to do off of this?
Number 8.
8,
And
9, and 10. It's only one part on number 8, it's only one part on number 9, and I think it's 2 maybe on number 10. Let's do it tomorrow night.
Oh, I forgot.
Do it.